Hello everyone, this is Pujita from MAD 19 team. Now I'm going to explain about my project Dynamic Data Masking for Secure Information Exchange. This project mainly focuses on enhancing data privacy in modern communication systems. As data is increasingly transmitting across various networks, protecting sensitive information from breaches and unauthorized access is a critical challenge. In companies, data is very secure and private information and a valuable entity. It has to be secured in many cases. There are personal identification information which is uniquely identified in a person. Example mobile number and email ID. In companies, there are several environments like development environment, staged environment, production environment. One such scenario, so what happens is data from the production instance brought into the staged instance. The real data is copied into staged instance and then testing. It has lot of risk being taken away by competitors or misused, and some automatic process running on the data and sending alert to the emails to actual customers, which could be a big problem in the industries. There are various scenarios we can see that data has to be masked or preserved so that it is not visible in the testing and staged environment. The goal is to mask basically make chunk characters or encrypt this information in staged environment so that nobody can see it or misuse it. Coming to the system architecture, this application represents the user facing interface, example, mobile application or web that requests data from the database. The application does not directly interact with the database but communicates through a dynamic data masking server. And the listening port act as an entry point for incoming data request. All application requests pass through this port before reaching the dynamic data masking service. And the dynamic data masking service is a core component that process incoming data request and applies masking rules, ensuring that sensitive information is masked dynamically based on the user roles and the access levels. Works is a real time, ensuring unmasked data is never exposed to unauthorized access. And this rule engine contains connection rules and security rules that determines how data should be masked. And the connection rules defines which user or applicants can access this masked or unmasked data. Security rules define how data should be masked, such as replacing sensitive information with different placeholders. And the database port, the security connection points between the dynamic data masking server and the actual database, ensuring that raw unmasked data remains in the storage but it is masked dynamically when retrieved based on the security policies. And this database store this original unmasked data securely. The masking process does not alter the stored data, ensure data integrity. And these management tools provide administrative control over the dynamic data masking service, allowing configuration changes. And coming to the algorithms, we have used logistic regression. Logistic regression is a binary classification algorithm that helps determining whether a piece of data should be masked or not based on the predefined security policies. It is useful for real-time decision making by analyzing the access pattern and determine if masking is necessary. And the decision tree classifier are efficient in categorizing data based on feature importance, making them ideal for determining masking levels based on the data context. They allow for rule based masking, which is useful in hierarchical security structures. And the random forest classifier, an assemble of multiple decision tree, enhance accuracy and reduce overfitting, making it reliable for masking classification. It considers multiple criteria before deciding whether to mask data or improve security. And K nearest neighbor algorithm is a supervised learning. It classifies target based on the majority classes among its K nearest neighbor. Learning from the training data by memorizing distance between points. Accuracy is evaluated on the testing set. And autoregressive integrated moving algorithm and LSTM. And I have also done testing on unit testing, integration testing, system testing, and performance testing. This is the output of the project. And I have also published it on April 5th. These are the reference. This is the code for the project. I have imported all the necessary libraries. and then load the data set. Here is the data set. Here is the accuracy. In total, 100 approaches were run. Here the data is masked. By combining these machine learning algorithms, the dynamic data masking can identify and classify sensitive data in real time and prevent unauthorized access data efficiently, optimizing masking strategies for security while maintaining the data usability. And here is the confusion matrix. That's it. Thank you.